My name's Peter Becker. I'm being joined by Cody Benkelman and Vinay Vishwandram. We are actually product managers at Esri and looking forward to giving you this session on imagery, what's new. Let me start with this slide. Many of you who have been here at previous imagery presentations will have seen this slide or a variation of this slide. It's an important one because it really helps outline the various aspects of imagery within ArcGIS. I mean, ArcGIS is a comprehensive spatial platform, and certainly imagery we consider the most comprehensive imagery system available. We have a lot of products, and throughout this presentation we'll be mentioning various products related to imagery, but really what we're providing is a capability, and we break that capability into 5 key areas. The first is content. In other words, how do you get access to the data? What content do you have, either within your organizations or that you want to get externally from your organizations? Once you have access to that content, how do you make it accessible? How do you actually manage that data? And that's really everything around about data management or image management. Taking that data, working with it to make it accessible to users. If that data is sitting on a hard disk under your desk, it's pretty useless. It's only when it's being accessed by other people or other systems that it becomes useful. Then there's the aspect of mapping or reality mapping. And that's really the processes by which we transform that imagery that's collected from sensors, if it was collected from sensors, into various products, such as true orthos, 3D meshes, or more traditional orthomosaics and DSMs. And this aspect of analysis, which is really about extracting information from imagery. And we have a lot of tools, and Vinay will be going over a number of those tools that are available and what's new in aspects of analysis. And then lastly, the visualization exploitation aspect, which is really how do we take that imagery and all the other spatial data and make it accessible for humans to visualize and interpret and work with the imagery and other data sets. So this presentation we will go through those different areas primarily, and we'll be covering a number of the different products and what's new. Quick thing about imagery. When we talk about imagery, we talk about it in a very generic sense, to mean really all types of remotely sensed data, but also data collected or processed as a result of different types of analysis. So imagery, rasters, remote sensing, there are lots of different modalities of this data. Yeah? It could be just an optical RGB image, but it also includes scientific data, oriented imagery, video, bathymetry, hyperspectra. You see there's a massive list of all the different modalities of imagery. And this is one of the unique aspects of ArcGIS and why we refer to it as being comprehensive. Because it's not just about supporting one type of imagery, it's really about supporting all the different types of imagery that are out there. And as you work with imagery, you will see that you need to use different types of imagery. And this all comes together within a single system. Another aspect of imagery is how do you actually deploy it? How do you deploy ArcGIS within your organizations? And there are really 4 key ways that you might use the ArcGIS imagery in your organizations. And you may use multiple of these. And we break it down into the 4: desktop, enterprise, SaaS, and managed SaaS. Let me go a little bit more detail into what we mean by each one of those. By desktop, we're referring to ArcGIS, we're primarily referring to ArcGIS Pro as really being an imagery workstation that has all the tools for working with imagery, but also all the tools for working with all forms of other spatial data. It can run on a laptop, it can run on a workstation, and it can run in the cloud. So this diagram is not about what's on-premise or what's in cloud. This is the different type of deployment. ArcGIS Desktop runs very well in a cloud. And Vinay will be showing you a little bit more about that and some exciting news about what's going on in Pro and in Desktop. Included in the desktop concept is things like ArcGIS Reality Desktop, and those are actually additional tools for working with reality products, and there are a lot of sessions about that this week. Drone to Map is another example of a desktop application. It runs on a computer, on your personal computer or a workstation. The second one is ArcGIS Enterprise. ArcGIS Enterprise is really for organizations wanting to manage their own infrastructure within their, within, let's say, an enterprise environment, which could be on-premises or in the cloud. So obviously there's ArcGIS Enterprise, and an extension of ArcGIS Enterprise is Image Server, which has been there for many years. What is new at 11.1 Kubernetes is not Kubernetes, but the ability for Kubernetes to actually run dynamic image services within Kubernetes. So it provides an additional scaling option for those organizations running under Kubernetes, running ArcGIS Enterprise in Kubernetes. You can now add the image services capability to Kubernetes. What's hopefully going to be coming later this year is the raster analysis aspects, and Vinny will be talking a little bit about what those enable. But that's one of the new aspects. The third deployment is SaaS, or in our case, ArcGIS Online. It's the ability to take your imagery, push it into ArcGIS Online, have it served from ArcGIS Online, and then also do analysis against that imagery without having to stand up any of your own infrastructure. And there are some new enhancements that are being applied to that. Been able to talk a little bit about those. SiteScan is another example of a SaaS solution. You upload your drone imagery, it performs all the processing and basically serves that data back. The fourth pattern is ArcGIS Image Dedicated, which may be new to some of you, although it's been available for a couple of years now. This is a deployment option by which organizations have their imagery in the cloud or use imagery which is already in the cloud. It may be open data sets and stuff like that in the cloud. And you want to spin up compute next to that cloud storage without having to actually manage that infrastructure. And there are various reasons why organizations want to do that. It may be because of sovereignty or they are mandated to maintain imagery in certain regions of the world, and therefore they may not be able to load it into ArcGIS Online for those reasons, or there's just too much data to load into ArcGIS Online. But it's really designed for organizations who don't want to actually manage the SaaS. So in that case, the data is stored in these in buckets, which are either organizational buckets or public buckets, and then Esri will stand up our server technology and the processing and analysis technologies right next to that processing, spin it up, perform the processing, and shut it back down. There'll be a session later this afternoon which will go a little bit more about it. If you look for a session about it, managing imagery in the cloud, it talks more about that. So that's really what we refer to as managed SaaS. Now for access to imagery, you have imagery, you're serving it. There are various ways in which imagery can be accessed. One of the ways is direct access. This would be for typically ArcGIS Pro directly connecting to a file system. A number of years ago, we added what we refer to as an ACS file. This is the ability for Pro to connect to cloud storage, efficiently manage those credentials and enable simple access to read and write to data in cloud storage. What we added as a beta in the JavaScript API is the ability actually for the JavaScript API to directly access cloud storage as well. So if you have, for example, cloud optimized GeoTIFF, you can directly access it. That data has to be public, it has to be open, but you can now also directly access the data through the JavaScript API. The other ways of accessing imagery, obviously tile cache. Think of world imagery. That's an example where we serve massive amount of imagery as very simple tiles. It's pre-processed data, it's extremely scalable, and ArcGIS Server can easily serve that tile cache. You can also serve it through ArcGIS Online and Dedicated. Tiled imagery is a step up from that. It allows not only simple RGB and elevation data to be served, but any multi-dimensional data or any types of bit depth data. What's important about tiled imagery is that the client is able to access that data and then perform things like, perform rendering of the data as well as reprojecting of the data. And what we've actually added recently is, in beta at the moment, is the ability to apply raster side functions. So Vinny will be talking a little bit about raster functions. Some of those are actually available now within the JavaScript API to run on the client side. I'll give an example a bit later. The fourth one is dynamic imagery. This is really the traditional image server, the ability that you make a request to the server performs the required processing. It actually queries the data, identifies what's required to cover the area of interest that you're interested, performs any processing required, and then returns that back to your application. Has very little load on the client, much more load on the server. Okay? Very, very powerful. And And then you have things like feature attachments. Don't forget those. If you take, for example, imagery with a mobile phone or a street view imagery, you can load those as features with attachments, and those images are attachments. And ArcGIS is really, really good at streaming that type of imagery very efficiently. And the last one is the I3S methods of serving data. If you were at the plenary and you saw things like ArcGIS reality and those 3D meshes being streamed, that's really the technologies to actually stream that data. So lots of different ways of making imagery accessible, and each one of them has its advantages. As ways of accessing this content, a lot of it's available to you. Hopefully you're all already using the Living Atlas, the Living Atlas of the world. It's curated content. There are over 120 imagery layers in the Living Atlas at the moment, and it has everything from world imagery, which is by far the most accessed service that we have. It's actually accessed 1 to 2 billion tiles a day from that service. It's a huge amount of access to it. But it also includes very important data sets. For example, all the Landsat data, the Sentinel-2, as well as now the Sentinel-1 data. So all the radar data being provided by the Sentinel-1 satellite is available in RTC, which is essentially a rectified form of that data. So you'll see there are a number of new services that we've been added, including the archive of the Landsat imagery, the Sentinel-2 data, and the Sentinel-1 data. And there are other number of data sets, such as the land cover, that have also been updated. From an image management perspective, as I mentioned before, we provide a comprehensive imagery management system, and that means that we support all the different formats of data. So there are over 150 formats of imagery that you may come across. Different formats from Mr. SID and ECWs and COGS and MRFs and JPEG 2000. There are 150 different formats of data. We basically support all the different types of imagery. We support all the meta information coming from the different sensors. So when you get an image from a satellite provider, it's not just an image, it comes with meta information which defines the orientation or the location of the satellite or the RPCs, the various parameters. All those sensor models we support so that you can easily just drag and drop that content into ArcGIS, and we will read the meta information and set up the processing chains appropriate to display, to accurately, where possible, and display that data. And we're continuously adding new sensors as more and more satellite providers or drone providers add data models. Then we have the optimized data models themselves. Within ArcGIS, you can certainly work with a single 1 or 2 files. Most people nowadays are working with tens, thousands, hundreds of thousands of files. And to do that, you need an appropriate data model. And over the years, Esri's developed a number of data models. The Mosaic data set is one that we've had for many, many years. It's the optimum one for managing, let's say, orthophotos and imagery from satellites. But we have other data models, LAS data sets designed for LiDAR data. Things like oriented imagery, which is handled more like street view and oblique imagery. And what we've added recently are catalog data sets and directory data sets. I'll come back to those in a minute. Then there's the aspect of once you manage the data, how do you make it accessible? That's really about how to efficiently share and stream that data. And again, we have, I mentioned before, different ways of streaming that data to various to the applications. And then identity is also very important and part of the whole thing. Not all the data that you have, you may want to just be made public. There are a lot of constraints that you may want to apply to the imagery, and identity enables you to, once you have those services, is to control who has access to what. I'd mentioned these data models, and 2 new ones are the trajectory data set and the catalog data set. So I wanted to quickly go briefly into what they are. The trajectory data set is really to support new, primarily scientific satellites, which are really creating profiles. They're basically going around the Earth, collecting profiles of sometimes height, sometimes very scientific measurements, carbon dioxide content and things like that. These satellites are going around the Earth. These are things like ISAT and Cryosat, collecting this data, which is very good for a lot of primary scientific applications. So the trajectory data set is a way of managing that. Similar to a Mosaic data set was very good at managing sort of orthophotos. Trajectory data set is really designed to manage these trajectory data. So you can bring in this data, which comes in as strips, but then very often you get the whole world covered in these strips. Each point has a different point in time, different location. And that needs to basically be managed. And then from that, you can easily create the derived products. For example, in this case, the changes in elevation, for example, over large areas. Another one I wanted to quickly focus on is the catalog data set. This is a new data set. If you were at the plenary, Jack actually called it out as something to look at. The catalog data set is a way of creating a catalog of layers. And if you know anything about ArcGIS, we have data sets, and then you convert a data set into a layer. And a layer is stored as an item in ArcGIS Online. It's stored as a layer within a Pro project file. And what a catalog data set allows you to do is to create really a catalog of all the layers, which could be in your organization or outside your organization. A WMS feed from FEMA would be a layer. Another one from NOAA would be another layer. And the catalog data set allows you to create a catalog of these different data sets, which is really just pointers to these data sets with some rules such that the client application, when you zoom and pan around, can add and remove the appropriate layer and also give you things like time. So it's a great way of bringing together different data sets to create a virtual collection of data, and it appears in a way like a intelligent group layer. So if I go back and you see on the right, you have these layers view. If you open it up, it's basically adding layers to your project file and then removing them if they're not applicable. So it allows you to support all the different capabilities of ArcGIS, but potentially with thousands or tens of thousands, 100,000 of different data sets. So that's it from the data management perspective. I'm going to hand you over to Cody to talk a little bit more about reality and what's new there.
Slide on 3. Thank you, Peter. Good morning, everybody. I'll give you a quick run through reality mapping. And if you haven't heard this terminology before, the terminology is new this year. We're defining reality mapping as the process of creating accurate digital representations of the physical world using imagery, LiDAR, or both. So reality mapping is about bringing reality capture and GIS together with an emphasis on geospatial accuracy in a projected coordinate system. And I have shown a couple of additional sessions later today. If you haven't seen any about reality mapping, there are 2 more today. The reality mapping tools allow you to create or update foundational content through highly automated processing. Using imagery from drones, airplanes, or satellites, you can create 2D products such as true orthos, orthomosaics of multispectral or thermal imagery, and extract elevation models where you have overlapping imagery. Videos can also become geospatial data products with the right orientation data. And 3D point clouds or meshes have become an essential part of what helps us understand our world. This content is spatially accurate and analysis ready for workflows including feature extraction and change detection. The 3D data products allow you to build a photorealistic GIS experience, which is the foundation for the creation of a digital twin. Reality mapping creates an intuitive 3D GIS that non-specialists can easily relate to, enabling engagement with geospatial data in a real-world context. So ArcGIS Reality is our software suite to provide a workflow for a variety of different inputs, including thermal or multispectral sensors and soon LiDAR, to generate the derived products to feed into GIS or BIM to perform a variety of analysis tasks, inspections, feature extraction, and more. So we refer to the various products as the ArcGIS Reality product suite. Drone to Map and SiteScan provide 2D and 3D products focused on drone mapping for smaller sites. And you can use Drone to Map when you have a small drone team, whereas SiteScan is a software as a service product designed to support larger drone programs conducting many, many flights. And if you have aerial camera or satellite data, ortho mapping in ArcGIS Pro can generate the 2D data products if you have the Pro Advanced license. But there's clearly a need for generating 3D products from professional aerial cameras, and so this year we introduced the new capabilities for desktop processing. For very large projects processing imagery collected by aircraft with a crew using metric cameras, we have ArcGIS Reality Studio. This is the professional application of choice for citywide and countrywide mapping, and ArcGIS Reality for ArcGIS Pro provides 3D reality mapping directly within the ArcGIS Pro environment. So it's designed for users working in Pro with a variety of sensors, and I'll come back to ArcGIS Reality in a moment. If we look at the different software app products in more detail, I want to start with the Flight app for the iPad. This is available free to all Esri users for planning and executing autonomous, repeatable drone flights to ensure that you capture quality data. And if you're capturing video, this app will automatically record the metadata that you need to bring that video into FMV or oriented imagery. New features this year include the ability to launch from a high point in your project area and then fly below the launch elevation. And we've also added support for the FreeFly Astro, which is an excellent mapping quality drone made here in the USA. And if you're not already familiar with Drone to Map, I'll quickly review some of the key features. Drone to Map is our desktop application for creating all of the derived products you expect from drone imagery. And this includes virtually any modern drone that captures high-quality imagery with GPS. Drone to Map can process imagery from multispectral sensors and provide the spectral calibration for many. We can also process thermal infrared camera data, and it will generate spatially accurate data products if you're using ground control or PPK or RTK GPS, and also provides some first phase analysis that you can tools such as volume measurement, and for multispectral data you can work with vegetation indices such as NDVI and plot spectral profiles for key land cover types. So this slide shows some of the new features released in the current version 2023.1. It includes automatic elimination of moving vehicles and reflections, enhanced quality in the output products, and an increase in the maximum project size to 300 gigapixels with the advanced license. Enhancements to the editing tools, which include the True Orthos and the DEMs. And you do now get True Orthos in the standard license, which was a change from the previous version. So the True Orthos in standard or advanced license. Moving to Site Scan, this provides a complete end-to-end workflow for your drones, from data capture in the Flight app to processing in the cloud, and powerful capabilities for managing your projects as well as your fleet of drones and pilots. New this year are the integration of the Reality Engine for improved quality in the output products, scalability to larger projects, and you're also able to create web map tile services, publish both tiled and dynamic imagery layers to ArcGIS Image for ArcGIS Online, and direct creation and publishing of oriented image catalogs for the individual drone images is about to be released. For users with ArcGIS Pro that need to generate orthos or extract DEMs from aerial cameras, including historical scanned film, or from satellite data, the advanced license of ArcGIS Pro includes ortho mapping with an easy-to-use workflow in the ribbon interface. Improvements this year have focused on the arrow triangulation engine in Pro, where the development team has improved both performance and accuracy, and this benefits the 2D ortho mapping as well as supporting the launch of the new products. So if you do want to use Pro to create 3D data products, we've launched ArcGIS Reality for ArcGIS Pro. This is a reality mapping extension that adds 3D capabilities into ArcGIS Pro, extending from the 2D processing of ortho mapping. And today this applies to drone and aerial imagery, and we'll be adding 3D data products from satellite imagery in the future. Bringing reality mapping into ArcGIS Pro also helps you automate production workflows by tapping into the large suite of geoprocessing tools that are available in ArcGIS Pro. And then for organizations that would prefer an application focused specifically on image processing without the additional functionality of ArcGIS Pro, ArcGIS Reality Studio is the solution for large area aerial surveys. It's designed for citywide and countrywide mapping, and it's optimized for working with the multi-head cameras that are used very commonly in survey aircraft. And before we leave reality mapping, there's one more new capability I want to highlight. We've always wanted to work closely with ASPRS, and with the continued growth in imagery from satellites and drones, I think many of us are facing the need to ensure our customers and end users properly understand how spatial accuracy is measured and reported. ASPRS is publishing a new specification to address this. I think it's just about to be published. And we're also hosting a web app that we've built to provide tools for making those accuracy measurements and then generating a detailed report based on the recommendations in the ASPRS specification. So this web app that I'm showing screenshots on screen has not been released, but it will be public. And if you'd like to see a demo, please, you can come find me on the exhibition floor or reach out to me after the UC, and we'll be happy to walk you through that and give you access to that application. And at this point, I'll hand over to Vinay for image analysis. That's 4.
Good morning. So I'll be talking about image analysis. Image analysis, it's really about extracting meaningful information from imagery. Now, Peter's talked about different types of data sets, different formats of data, different data modalities that are natively supported within ArcGIS. Now, all of these different data modalities, you can perform different sorts of analysis, ranging all types of analysis, ranging from distance modeling, suitability analysis, GeoAI, time series analysis, object detection, predictive analysis, so on and so forth. And through this conference, through all of the workshops that you have attended, you've probably seen a lot of sessions where we've shown you examples of different types of rich analysis that is performed on different data types. Now, what's new and improved, we've added support for the trajectory data set, which Peter's already explained, he's talked about. We've added new analytical capabilities on the trajectory data sets. There are new radar sensors and new processing capabilities on these radar sensors. Deep learning is an evolving topic, and you've seen a lot of sessions already, I'm sure by now, at this UC. So we've added new tools, new toolboxes, more than 30 different pre-trained models. We've added raster analysis capabilities within the map viewer, in quotes, new map viewer. So you can perform deep learning there, we have more than 26 different tools, and you have access to raster functions as well. The function editor it will be coming in anytime soon. And then we've made several API enhancements as well. And lastly, something I'd like to really call out is all of this analysis that I'm talking about is cloud agnostic. So while you can run it on your desktop, you can run it on your enterprise and online, you can have your own deployments in various clouds. That includes Google Cloud, AWS, Azure, and so on. Now, this is something, Peter's already talked about deployments, but something I want to highlight again. All of this analysis, we have our key products, our key offerings. Our flagship desktop product is ArcGIS Pro, then we have ArcGIS Image for ArcGIS Online, which is a SaaS environment, and then we have Image Server, which is our enterprise environment, and lastly there's Image Dedicated. All the analysis is available in each one of these deployments, and it really depends on the type of user you are. If you want to do your desktop, if you want to do your analysis on your local machine, on your desktop, you can use ArcGIS Pro, and we have an experience which is ArcGIS Pro, and we have the Python API which can be accessed through notebooks, and then you can invoke all of this analysis, both desktop analysis as well as enterprise analysis, through the Python API. Likewise, for the online users or users who do not want to go through the pain of deploying any form of software or work with their infrastructure, we have ArcGIS Online. A lot of these analysis tools are available there as well. If you want to scale your analysis, we have ArcGIS Enterprise Image Server. Now I'll go through some of the key capabilities. I'll start with GeoAI, or Geospatial AI, as you may refer to it. What's the way we have broken down GeoAI is there are 3 key data structures that we support. One is text, and within text, the possibilities are you can perform entity extraction. So given a report, you can extract things like coordinates, type of incident, so on and so forth, locations, and you can create spatial databases. Then there's text classification, there's text transformation. When working with vector tabular data, you can perform predictive analysis, classification of data, regression, you can perform time series forecasting, which can also be done using imagery and remote sensing. Obviously, with imagery and remote sensing, all of those data types that I talked about is natively supported. In this release, we've added 30 Pre-trained models, we've added the GeoAI toolbox, which enables you to do a bunch of functionality, which I'll cover briefly. There's AI-assisted labeling, automatic deep learning, and we've added new model types as well. I'd suggest you attend the session tomorrow. It's at 9 o'clock. It's focused on using deep learning for feature extraction and classification, and we're honing in on imagery. Diving a little deeper into imagery capabilities when it comes to working with geospatial AI, all of those different data types, data modalities that we talked about, you can perform AI on those data sets. Now, just a couple years ago, we just worked with overhead imagery. All you could do was object detection. This system has evolved. You can do object tracking, multi-object tracking from video, 3D point cloud classification, 3D point cloud object detection. You can work with 3D scenes. You can perform time series analysis on image cubes and multidimensional data sets. You can also work with street view imagery. And lastly, we've taken our analysis to the edge through Survey 123. And that's something you must have seen at the plenary. So those are the different data types, right? And different data modalities. The different tasks that we support, that has also been enhanced. It's gone all the way from object detection to object classification, edge detection, change detection, pixel classification, and like in the movies, image enhancement done by super resolution techniques. Next is pre-trained models. With pre-trained models, what we're trying to do is democratize AI and make it a little more easier and easily accessible for our users, making AI more approachable to our users. With this, our users don't have to shy away from the concept of AI. You bring in your imagery, summarizing it quickly, you bring in your imagery, you use these pre-trained models, and you can extract features. Out of the box, we provide you with more than 60 different pre-trained models. These models are designed to perform specific tasks in specific geographies using different types of data types, different types of imagery. It also works with, obviously, video, text, and so on and so forth. And we've designed these for different sectors: conservation, natural resources, utilities, public safety, state and local, so on and so forth. Now, getting into what's new, this is the general pipeline. Firstly, I'd like to highlight. When it comes to working with AI, you can perform labeling within ArcGIS, prep your data, train a deep learning model, and lastly, perform inferencing. Now, given that you're within a GIS, you're within the context of a GIS, your image management, I mean, when do you run AI? You typically run it when you've got a large collection of images. Peter's talked about image server, which will enable you to scale images, scale serving out of images. So users working in the AI domain, they do not have to worry about image management. So we have that is plugged into this AI pipeline. And the results can be used for, you can perform downstream analysis on the results using geoprocessing tools or raster functions. And out of the box, as you're aware, there are more than 2,000 different geoprocessing tools. So in terms of what's new, AI-assisted labeling. Labeling can be daunting. It can be really, really difficult. But with AI-assisted labeling, as you can see here, click, 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 and automatically the system is just going to pick features for you. So those were planes, and right here we're capturing houses. So it's significantly simplifying the process of capturing training data. Next is we made enhancements with model training. Now, our users constantly ask us, what are the models that you natively support? SSD, RetinaNet, UNet models, etc., etc. There's so much that we support. There are more than 50 different models that are natively supported for different tasks, which is excellent. It's awesome. Everybody likes it. Problem is, it's a double-edged sword, right? Which model am I supposed to be using for what scenario? So this is the traditional UI, which you see. Pick a backbone, pick your model type, and then run the tool. But with train using AutoDL, all you have to do is provide your training data, define which models you want the system to evaluate for you, hit run. It'll come back after a couple hours or the time that you define, saying, this is the priority of models, and because of these reasons. This is the F1 score, This is the precision, this is the recall rate, and this is the accuracy. Beautiful tool, simplifies trading significantly. Next is multi-feature extraction, a part of inferencing. Let me bring this up, it will give you more context. In a single shot, I can provide multiple models and multiple geoprocessing tools that do post-processing. So in this case, I'm doing building footprint extraction, and it will also do a building regularize for me. And then there's road detection, parking place detection, so on and so forth, parcel detection, all in one shot. And lastly, as an extension to inferencing, we've also taken our analysis to the edge. Through Survey 123, you can perform direct inferencing using TensorFlow-like models. Deep Learning Studio, relatively new product. I keep highlighting it because it's not a standalone product by itself. If you have Image Server, you just get the product. It's just available for free within Image Server. The whole point of this, it's a web-based application that enables you to scale your processing. Now, it's not just scaling your processing, it's a collaborative environment. Training is daunting, as I'd mentioned. So with this collaborative environment, you can scale out your training process, send it to a bunch of users, everybody can train simultaneously, or provide you with training data simultaneously. And that's something which I encourage you to come down to a booth, and I can show you a little more about. Now, image science, previously, historically, you've probably seen me doing the slide as multiple slides, working with time series data, working with multidimensional data, working with trajectory data. But really, this system has really evolved into an image science platform or image science workstation. So there's a boatload of functionality that we've added, calculating best pixels, simulating scenes, performing spectral classification, several API enhancements for all of these different capabilities that you're seeing on the screen. And this is driven by a lot of our users. Radar capabilities, I'm excited about radar, and what we've introduced in the previous release of Pro was support for Sentinel-1, processing of Sentinel-1 and basic analysis capabilities using raster functions and a suite of deep learning packages. And now we've expanded our support for sensors by expanding out to commercial sensors like RCM and ISI. In the next release, obviously, this is just going to continue to improve. We're adding Capella and other sensors as well. And we have the complete processing pipeline so that you get analysis-ready data sets out of this. And we have more than, I think, 6 different pre-trained models available on the Living Atlas, so you can perform analysis or feature extraction on radar data. Another announcement, you probably saw this in the Living Atlas session. We've now exposed the Sentinel-1 data set as a service, as a tiled imagery layer, which you can work with directly within the Living Atlas. Next is ArcGIS Pro. Now that I talked about all of the key capabilities or sub-capabilities, I'll talk a little bit about our key products that drive these capabilities. ArcGIS Pro, out of the box, yes, you don't need extensions and everything. Out of the box, there's basic functionality that's available. We made enhancements to the extensions. There's reality mapping. There's a boatload of raster functions that you can work with, like cloud removal, least cost assessment, thermal assessment, distance accumulation, allocation, so on and so forth. But like I said, image analyst, spatial analyst, and to an extent 3D analyst are the key extensions that drive imagery analysis within ArcGIS Pro. And these are the sub-capabilities within Image Analyst. And if you noticed, I talked about each one of these topics. So essentially, all of those capabilities that I talked about is available within the Image Analyst extension. SAR, motion imagery, time series analysis, change detection, GeoAI, so on and so forth. So essentially, everything that was new that I talked about is new to the ArcGIS Image Analyst extension. Again, there's a session today, it's a little later today, that's focused on the Image Analyst extension, and we go through everything in there. I'd suggest you attend that session to get more information. The next is ArcGIS Microsoft Planetary Computer, something Peter talked about. It is a new offering that we have on the Azure Marketplace. If you have your own Azure account, Azure credits, and you have Esri software, you can combine the two, and you're essentially taking ArcGIS Pro, or you're taking a desktop product to the data which is the Microsoft Planetary Computer data. Instead of going on a slide, I can quickly show you a demonstration on what's available. So for instance, over here, I can head over into the Azure Marketplace and we search for ArcGIS for Microsoft Planetary Computer. This is where we come. You can say, get it now. Once you reach here, this spins up. It takes you to the process of creating a new virtual machine. And then you can go, it's a really simple wizard. You say create, you define your virtual machine name, your username, your password for the instance, you connect to the machine, and you're good to go. So this is what it looks like. You can connect to the instance, download a remote desktop connection, and here is my remote desktop connection. I've just remoted into that machine. Here you have access to all of these different data sets that is provided by Microsoft. And this list is just growing. It's petabytes worth of imagery that you can work with, global data sets that you can work with. And along with just Pro, that is next to that machine, next to the data, we provide you the deep learning libraries, so you do not have to install the deep learning libraries as well. It is deployed out of the box. You can use deep learning algorithms, and we provide you with connection files to those data sets. So you go in here, access the ACS files, and this gives you access to each one of those folders. So it looks like just another folder on your machine. You can just drag these data sets into your map. Like in this case, I pulled in two data sets from the 3DEP. One is a terrain model, one is a surface model, and then the rest of it is pure ArcGIS. I've just used raster functions to process this. This is one of the surface model that I did, the hill shade that I derived from the surface model, and the hill shade that I derived from the terrain model. In a matter of clicks, I could get going with the data set. Again, we're demonstrating all of these capabilities that I talked about at the booth. Next is ArcGIS Image for ArcGIS Online. This is also a relatively new capability that we've added. It's actually been a couple years. We're gradually starting to see uptake in this capability, which over time, we're going to enable users to perform analysis against these living atlas layers that we just talked about. We made several API enhancements, so you can run notebooks and you can run your analysis and image management within notebooks using ArcGIS Image for ArcGIS Online. Like I said, more than 26 different raster tools are added to the map viewer, including time series analysis and deep learning. Analysis history is beautiful. It's like analysis history within ArcGIS Pro. You can invoke geoprocessing tools, and you have a history of all the analysis that you have performed within that map viewer instance. So you can always come back to that. You can identify the parameters you use, the layers you use, so on and so forth. Lastly, for the developers in this room, data scientists in this room, or the scripters, we continue to make enhancements to our API. We have a strong platform story when it comes to working with imagery, a developer platform story when it comes to working with imagery. There are enhancements to JavaScript API, which Peter's going to be talking about. ArcPy has several functions. It gives you access to the complete system. And ArcGIS API for Python is a lightweight API, which is web-based, so you can access your WebGIS and work with your WebGIS. And with that, I will hand it over to Peter, who will talk a little bit about visualization.
Thank you, Vinay. So let's get into the fifth component of this discussion, our presentation, visualization, exploitation. This is really about how humans interact with imagery and the system. And we break it into really sort of three subcomponents of that. One is how imagery is seamlessly integrated into the complete system. As you've seen, it works directly within ArcGIS Pro. It works in the web applications, the mobile applications. So this is about enabling imagery to be a foundational part of the complete system, allowing users to look at the imagery along with the vector data and sort of create mashups between all these different data sets. The second aspect is about the powerful tools for analysis. Vinay had mentioned some of those, specifically, for example, in ArcGIS Pro, its ability to do things like display of stereo imagery. If you go downstairs in the imagery island, you will see a number of stereo workstations being able to do photogrammetric stereo, in other words, being able to see images from planes and drones and satellites in stereo, which allows much better interpretation, as well as we refer to as 3D stereo, which is the ability to display, for example, 3D scenes and 3D meshes in a stereo view. There's a big display down there. Go and have a look at that. It's pretty impressive. So there are a lot of tools for powerful analysis tools. Also includes, for example, working with satellite imagery and being able to transform the image, the map, into the image space. So instead of rectifying the image to the ground, which is typically what we do in GIS, to actually take the map data and transform it into an image, which basically makes the image the center of what you're doing. And there are various reasons why that is done to ensure that there's no resampling of the data and things like that. So those are sort of the powerful tools for analysis. And then we have the aspects of empowering the end users. This is really the integration of imagery into things like story maps, into dashboards, and things like that, enabling imagery to really enable you to create those applications that end users can very simply use imagery in. Another aspect of visualization is, although we cover it from a management perspective, analysis perspective and everything, but a lot of people see it from a visualization perspective, and that's really the support for oriented imagery. So oriented imagery really is imagery that comes directly from a sensor. It could be nadir looking, in other words, looking straight down, but very often it is imagery for a drone that is looking, let's say, oblique imagery or aerial oblique imagery. It can be satellite oblique imagery. It could be video imagery. It could be street view imagery, 360 imagery, 360 video. It's all the sort of non-traditional imagery from a GIS perspective. So oriented imagery really is a way of managing that data, but it also provides the interface by which users can very easily consume that data within their applications. And it brings together all these different sensors together, so you're not having different experiences each time. So what we've added recently is the oriented imagery, update to the Oriented Imagery Explorer, which is an application that allows you to interact with this data very easily. The ability to publish these oriented image catalogs from SiteScan, as well as adding additional additional image measurement and feature extraction capabilities, number of quality improvements. There is actually a big change or enhancement coming up in the next release of ArcGIS Pro. Oriented imagery would actually be incorporated directly into it. It's no longer going to be a plugin, and you'll also see the similar happening in the on the website as well. So it'll just become a core component of ArcGIS imagery as the imagery solution to work with all this billions of images that are available as oriented imagery. The catalog layer is also, from a data management perspective, important, but it's also important from a user perspective. As I mentioned, it allows you to create a catalog of the data, and if you see in the bottom left-hand side, there's a small video. As you sort of zoom into different areas, the different data sets are basically being added to the map, although they are coming from different data sources. This is not one server serving one data set. These are multiple servers from multiple organizations, apparently working together to serve these different data sets, although they're actually coming from as I said, from multiple organizations and multiple data sources. So catalog layers support all forms of layers. Obviously, imagery is also a layer. Other enhancements are really in the map viewer and the APIs, and it's best to actually show this, but we continuously enhance the APIs and the map viewers to extend its imagery capabilities. Just want to give a couple of examples. The first one is the support of cloud-optimized geotiffs. This is actually a cloud-optimized geotiff sitting in the cloud, and as I pan and zoom around, it's going to access that data, display the imagery, read in the tiles. They're basically being streamed in from the data source, but you can also define functions on them. So you could say, this is the agricultural band combination. I want to, for example, see color infrared, and it will actually apply the functions on the data. So it's streaming data directly from the web, from cloud storage, directly to the client application, displaying it and apply rendering to it. This can also be scaled up, and this is an example of tiled imagery. So tiled imagery is designed to handle these. This is a very, very large data set from NAPE imagery, which is available in this case as tiled imagery, and we can zoom into a particular area. In this case, it's streaming those data values. This is not RGB image, it's actually 4-band imagery. What we now allow is the functions to be applied on the client side. So if you go to the function template, you can see that there are a number of different functions here. I could say I want to apply this custom function, and it applies it. No new data got transmitted from the server to the client. Yeah? It's just the client is now not only reprojecting the data, in this case to Web Mercator, but it's actually applying the functions on that data to render it. And you have a lot of control on that rendering that can be applied to those functions. The other one, I don't know why it signed me out. Let's go back into here. Is the support for multidimensional data. So let's go to a more interesting part in here. So this is really additional interfaces that we've added to the map viewer that allows you to work specifically with multidimensional data. So I can look at the multidimensional data. I can define, for example, the extent that I'm interested in working in, and then if I want to sort of say play the data or go to particular different points in time, and what it's doing is it's streaming through this multi-dimensional stack. It's identifying the data sets that are required for my location at a specific point in time, and streaming those to me, so I can have so I can quickly visualize these data sets. One thing I'd like to do is to highlight where a lot of this information is from. There is a website called the Imagery Workflows website. I highly recommend you go to it if you want more information about best practices of how to work with imagery. We keep updating it with a lot of content. There is new content being added. Cody had actually mentioned the accuracy assessment tools, for example. That's where those tools are going to be. So it's a really, really good set of resources that help you work through different types of imagery. I didn't put a QR code. Just look for Imagery Workflows. It's the first thing you'll find. So with that, I just want to sort of conclude that ArcGIS is a comprehensive imagery system. This is the same as the first slide, really highlighting that it has these 5 key capabilities which are encapsulated in the various products, ArcGIS products. But it really provides the ability to work with imagery all the way from that source content all the way to the visualization of the imagery. One thing I'd also like to invite you to is there's a new imagery and remote sensing user group. If you please have a look at that. We're going to have the first meeting will be near the end of September. So you're all please invited to have a look at the remote sensing user group, and you can use that as a way of creating a community to help solve problems and define requirements and stuff like that, and start up more detailed conversations with Esri if you're not already having those discussions with account managers or solution engineers. So do have a look at that and look to become a member. Also, highlight again, don't forget, please do fill out the feedback forms. They are important. It helps us to refine these presentations from year to year. So do look to answer the questions on that. We'd appreciate that. With that, I'd like to say thank you for attending it, but we will basically carry on for some questions. So thank you for that. So do we have any questions?
Mm-hmm. Are you able to configure it so that you can access your own data? Let's say you've got an existing Azure presence with the Descubra.
Yep. So with the new Microsoft...
Repeat the question.
All right. So your question is, with the new Microsoft Planetary Computer, can you access your own data store that is available or plugged in to your Azure account? Yes, you can do that. By default, if you use the Azure application, you can specify how much of a disk space you need. And once you're done with that, you get into your Azure dashboard, where you can configure everything from your network to your security, and you can attach additional disks as well.
So let's quickly go online. There's a question, the highest votes online, which might be interesting to people. It's actually Divine. Is it possible to do object detection, classification, and historical aerial imagery without using image analyst license?
So we'll break it up into two. One is it possible to do object detection on historical aerial images? The question came in before we jumped into the GeoAI section. So as you're aware by now, yes, you can do object classification, object detection on all forms of all data modalities natively supported within ArcGIS. That includes historical aerial images. But do you need the image analyst extension? I've mentioned in the answers, but I believe there's more clarification required. You need the image analyst extension if you want to run the analysis in desktop. If you want to run it in image, if you want to scale it out using enterprise, you need the image server extension. If you want to do deep learning using online, you need the ArcGIS image for ArcGIS online user type extension. And for these different categories or extensions, they're not dependent solely on the image analyst extension. So it really depends on the deployment, and accordingly, you need the right extensions or licenses.
Go on, Kazim.
Thank you for the great information. The QCR you put for the image user is not really working.
Okay, so there was a question from saying that the QR code that I used here is not using. I actually had, somebody else had mentioned that yesterday. I checked it and it worked on my machine. I'm not quite sure why it doesn't.
Community.com, Safari cannot open the page because...
Okay. Okay, at the moment we just have to so hopefully we'll get that fixed, that URL fixed, but... Okay. Okay, yeah, it seems to be strange. It works for... I don't know why. Sometimes it works and sometimes it doesn't. Maybe, yeah, we have to check the different browsers. Sorry about that.
Is there any plans for having support for hyperspectral imagery at all in the future? I've tried before and it's
So the question was, is there going to be support for hyperspectral imagery coming in the future? So we do support hyperspectral imagery as a data model, but I would agree that the interface at the moment has not been optimized for it. That is certainly something that we're looking for. So if you take a hyperspectral sensor and add it to imagery, you will see all the bands, but you will see 2,000 bands fall out. You can apply functions and stuff to do it, so you can say, I want to apply a function chain, and you define all the different bands. Then you basically create a raster function, and what the user would typically see is just, I've got 3 raster functions, they pick it. It works like that. Yes, there are improvements that we intended to make to work better with hyperspectral data and add some analysis tools, but we're not going to add lots of huge amount of hyperspectral tools. There are other partners that we have who focus in those areas. So.
The QR is fine, that's the browser problem.
Okay, so the browser is the problem. Google. Okay, the QR code does work, you just got to use the right browser. We should check that. Any other questions? Yeah.
So, catalog.
Yep.
We're embarking right now on taking all of our raster data. We haven't had a really good system to push it out to the rest of the company. And so, one of the things that we did was started down a path of not using the catalog, like you guys talked about today, but more just kind of creating their own catalog using the file index from the mosaic data sets and kind of doing it the long way. Is that definitely kind of the best practice in cataloging the imagery content that we have? It seems like, I guess it's not really clear.
Okay. So so the question was related to trying understanding where the catalog layer fits into different aspects. There was actually a presentation yesterday which we did more about, let's say, the image management aspects. But there are different concepts. One is to use stack. Many people understand, have stack. That's really a way of defining meta information in a normalized manner for each data set within your organization. Yeah, that's what was called a stack item. And we're going to be providing some tools to help manage those stack items. Very often if you connect to, for example, Landsat or Sentinel in the cloud, they will provide a stack catalog. But for most organizations, the issue is how do you create those items? So we're actually going to be providing some tools to enable you to create those stack items. They are stored with the data, but you can crawl them to create what's called a stack catalog and serve that. So that's a great way of going through all your holdings and finding these different data sets. Once the stack only contains the key meta information, what you then typically want to do is you want to manage that data and take all, let's say, the elevation data within your organization and turn that into a mosaic data set. The mosaic data set will extract all the meta information that's available, whether it's in the stack catalog or not, allow you to manage that and define the functions to be applied on it, yeah? How to clip it, and things like that. So that mosaic data set is the way that you actually manage these different collections. It's not for managing all the data, it's saying, I want a mosaic data set of all my elevation data, I want a mosaic data set of all my multispectral data, I want a mosaic data set of all my satellite data. And you manage that, it becomes accessible in the desktop applications, but you can then serve that as a dynamic image service and serve it. You can also make it very easy to transform it into another form. You can say, I want to just generate a tile cache of it. I just want RGB. Create a tile cache of it and serve that. So that's where the mosaic data set comes in. What the catalog layer does is enable you to take those different layers, which could be an image service, it could be data sets, all types of data sets you have, and create a catalog which defines really the extents and key meta information about the data. So it's not defining the processing to be applied to it. It's designed mainly to go across systems, yeah? It's not only the data in your organization, it's the data that might be served to you by another organization. And you can then create a catalog of all that and see what's available, and then when you zoom in, it'll basically load those layers coming from different sources. So it's different. What you will see is that we also use that all the way back to the beginning for creating those stack items. How do you crawl through your, 200 directories of data and crawl that to get that meta information? We're going to be using a catalog layer there. So it's used for two different things, but it's not really a replacement for a mosaic data set either. Okay, I think with that we're out of time, so thank you very much for attending and hope you enjoy the rest of the user conference and the rest of your time in San Diego. Thank you.
And for those online, I think we've answered most all the questions, but reach out to us via email if you have more questions. Thanks.